Welcome back. Greedy algorithms. Optimization problems are meant to find solutions to a given problem that either minimizes or maximizes the value of some parameter. So optimization problems are the kind which are meant to either minimize or maximize the given situation. For example, if you're running a factory, you want to maximize profit or you want to minimize running cost. So these are problems which are called optimization problems. For example, find a route between two cities with the smallest total mileage. So not just the fastest way necessarily, but the smallest total mileage. So that's an example of an optimization problem. Algorithms that make what seems to be the best choice at each step are called greedy algorithms. Once we have a feasible solution, so that is, you get a solution from a greedy algorithm, we need to determine whether the solution is an optimal one. That is, does it give you the best solution, the maximum or minimum as mentioned? For example, consider the problem of making n cents change with quarters, dimes, nickels, and pennies using the least total number of coins. Least, that is, minimum number of coins you want to use. So, for example, you have 123 cents. So, make change using quarters, dimes, nickels, and pennies, but you want to be using minimum number of coins. So for instance, 123 cents, right? Well, I could take 123 pennies, but that's 123 coins. So how about I reduce number of coins, right? So suppose I take with the largest denomination coin, that is quarter. Quarter has 25 cents. Each quarter takes care of 25 cents. So that will reduce number of coins I need, right? So how many quarters go in here? 4 quarters give me 100 cents. So what's left over? Left over is 23 pennies, 23 cents rather. Okay, so I no longer can use a quarter. So I used just enough quarters to take care of a large number of cents. I have only 23 cents left. I'm allowed dimes. A dime is 10 cents. Nickel is 5 cents. Pennies are 1 cent. If I take pennies, I will have 23 coins more, but I can do better. How about 2 dimes? 2 dimes takes care of 20 cents. So what's left over now? 3 cents. Well, no nickel can be used because nickel is 5 cents. So that gets me 3 pennies. Left over is 0. So I am done. So 123 pennies, which were going to be 123 coins, we reduced it to how many coins? 4 plus 2, 6 plus 3, 9 coins. So this is much less than this, yeah? So we use the least total number of coins. So this is an example of how you would use a greedy algorithm. So what did we do here? We used the highest denomination and took as many as we could. So that's the greedy part of it. We looked for the best solution at each stage. Okay. Procedure change. C1 through Cn, these are values of denominations of coins. Highest denomination is C1, second highest is C2. So, well, in some other world, you may not have quarters, dimes, nickels, and pennies. You may have some other denomination. So this is a general situation. So you have R different denominations. Highest one is C1, next is C2, so on. So first start with the highest denomination. I going from 1 through R. So you're looking at how many coins of each denomination you need. DI counts the coins of denomination CI. So initially DI is 0. As long as the value n is a positive integer, okay, the input number of cents, for example. As long as n is greater than the denomination, you can increase DI. Yeah, so in all, basically DI is the number of CI coins used. Every time you use a CI coin, reduce the value of n. Keep doing that. Once you have exhausted as many C1 coins you can have, move on to C2 coins and so on. And you would do this as long as the leftover, that's the leftover, is greater equals your coin value, the denomination value. So if n is a positive integer, then n cents in change using quarters, dimes, nickels and pennies. Using the fewest coins possible, okay. When you do this, you see, you can have, look here, we had 2 dimes, 3 pennies, 4 quarters and so on. You can have at most 2 dimes, at most 1 nickel, at most 4 pennies. Cannot have 2 dimes and a nickel. The amount of change in dimes, nickels and pennies cannot exceed 24. Dimes, nickels and pennies cannot exceed 24. So this is a requirement. What does that mean? Let's see. If you had more than 2 dimes, if we had more than 2 dimes, okay, more than 2 dimes, then we have at least 3 dimes. 3 dimes, that is, for 30 cents, for at least 30 cents, we used 3 dimes. But why would you? Instead, you could have used 1 quarter, that's 25 cents, and 1 nickel, that's 5 cents, right, to get to 30 cents. Yeah, if you have more than 30 cents, but basically instead of 3 dimes, you can reduce it to 2 coins, 1 quarter and 1 nickel. So we could have used only 2 coins, one quarter and 1 nickel. Okay, you may have more cents here going on, but at least this count of 3 coins got reduced to 2 coins. All right, so you don't need to ever have 3 dimes. Anytime you have 3 dimes, you replace it by a quarter and a nickel. If you have more, say if you have 5 dimes, then you use 2 quarters already, you see. Now, what if you have more than 1 nickel? If we had more than 1 nickel, then we had at least 2 nickels. At least 2 nickels, that is, we have at least 10 cents worth of nickels. But why would you? Every 10 cents can be replaced by 1 dime. That is, every 2 nickels can be replaced by 1 dime. So you shouldn't really have two nickels. The moment you have two nickels, replace it by one dime. That already reduce the number of coins used. All right. Likewise, if you have more than 4 pennies, if we have more than 4 pennies, then we have at least 5 pennies. More than 4, right? So at least 5 pennies. That is, every 5 pennies can be replaced by 1 nickel, thereby reducing the coin count. You see, why would you use 5 pennies when you can use 1 nickel? Now, suppose you have 2 dimes and 1 nickel. Suppose we had 2 dimes and 1 nickel. Well, then replace these 3 coins. You see, 2 dimes and 1 nickel. So 3 coins by 1 quarter coin. Yeah, so instead of 3 coins, you just need 1 coin. So do that. So if the total amount of change, okay, the last issue, if the total amount of change in dimes, nickels and pennies, if the total amount of change in dimes, nickels and pennies exceed 24 cents, so you have a few dimes, some nickels, some pennies, and they exceed 24 cents, then they are worth at least 25 cents. So use 1 quarter for every such change, thereby reducing the number of coins. You see, anytime you are at least 25 cents, use a quarter instead of all these other coins, because 1 quarter is just 1 coin and it takes care of the 25 cents. All right. So the lemma says precisely what we argued. Do not use more than 2 dimes. Do not use more than 1 nickel. Do not use more than 4 pennies. And do not have 2 dimes and a nickel. Moreover, the amount of change in dimes, nickels and pennies shouldn't be more than 24 cents. Okay. Here is an important theorem. The greedy algorithm, that is this algorithm we just saw, produces change using the fewest coins possible. So how do you prove? Well, any optimal algorithm, how do you know that you actually got the fewest coins possible? Any optimal algorithm would use the maximum numbers of quarters first. You would use quarters first, any optimal algorithm. Otherwise, you would have 25 cents to be covered. Well, 25 cents by this lemma that we just saw, we cannot have that, right? Anytime you have 25 cents or more change from dimes, nickels and pennies, well, replace it by a quarter. Therefore, after using maximum number of quarters, we have at most 24 cents left. You see, because the moment you have 25 cents, you can make a quarter out of it. So at most you have change of 24 cents. Now those 24 cents, well, you will first use dimes. Keep proceeding thus. You get that the greedy algorithm is indeed the optimal algorithm. Okay, so that completes the proof of this theorem, which completes the lesson 11. Okay, we'll continue with lesson 12, division algorithm, in our next video. Until then, bye.